The mean travel time to commute to work in Dallas, Texas was 25.3 minutes in 2006. The Department of Transportation in Dallas just reprogrammed all the traffic lights in an attempt to reduce travel time. A recent sample of 2,500 commuters produced a mean travel time of 24.9 minutes and a standard deviation of 8.4 minutes. At alpha equals 0.10, is there sufficient evidence to suggest that the mean travel time in Dallas has decreased due to the reprogramming of the traffic lights? Before we start the problem, we'll have to find the claim and the complement. In this case, the claim is the travel time decreased from the original time of 25.3 minutes? So we're claiming that the mean is less than 25.3 minutes. The complement to this is the opposite. So the complement is the symbol in the opposite direction, and since this does not have an equal sign, this one must have the equal sign. So the complement is that the mean is at least 25.3 minutes. We can start step 1. In step 1, we have to state the null hypothesis and the alternative hypothesis. The null hypothesis is always the one with the equal sign. In this case, it's going to be the complement. The mean is at least 25.3 minutes for the null hypothesis, and the alternative hypothesis is going to be the claim. The mean is less than 25.3 minutes. In step 2, we have to state alpha, the level of significance, and in our case, alpha is equal to 0.10. In step 3, I have to decide if we're going to use T or Z, and that depends on the degrees of freedom. The degrees of freedom is n minus 1. In our case, we have 2,500 commuters, so the sample size is 2,500 minus 1 from it. We get the degrees of freedom is 2,499, which is clearly greater than 1,000. So we are going to use Z in step 3. Z equals x bar minus mu divided by s over the square root of n. X bar is the sample mean, and we have a sample mean of 24.9 minutes. The mean is the original time of 25.3 minutes before the reprogramming of the lights. S, the standard deviation, is 8.4. N is the sample size. We had 2,500 commuters. Let's plug in the value for x bar. X bar is 24.9 minus the mean, which is 25.3, divided by the standard deviation 8.4 over the square root of 2,500. If we plug this into our calculator, we get a value of negative 2.381. In step 4, we're going to find the p-value. In order to figure out the p-value, we have to look at the alternative hypothesis. The alternative hypothesis was that the mean was less than 25.3 minutes. Since this is a less than symbol, we know this is a one-tailed test. I do not need to double the p-value. Since it is a one-tailed test, we do not need to double the p-value. And in step 3, we found that the z statistic was negative 2.381. So we're going to find the probability z is less than negative 2.381, and that's going to give us our p-value. Using our z table, the area to the left is 0.0087. Again, this number is from our Z table. So, step 4, we have the p-value is equal to 0.0087. Step 5 is our conclusion. I always ask, is the p-value less than alpha? Recall the p-value was equal to 0.0087 and our alpha was 0.10. So yes, the p-value is less than alpha. So we reject the null hypothesis. There's strong evidence against the null hypothesis since the p-value is less than alpha. We reject the null hypothesis. There is enough evidence to conclude the mean. And remember, the conclusion is always in terms of HA. Recall HA was the mean is less than 25.3 minutes. So we're going to say we reject the null hypothesis. There is enough evidence to conclude the mean travel time is less than 25.3 minutes. Let's try the problem now on the computer. I want to make sure to select the calculator that says hypothesis tests for a population mean given statistics calculator. So make sure you select that calculator. We know the standard deviation is 8.4. The sample mean is 24.9. The sample size is 2,500. And we know the population mean is 25.3 minutes. I want to make sure to select the alternative hypothesis, and the alternative hypothesis says that the mean is less than 25.3, so we'll make sure to click the less for the HA. Click calculate, and we have our test statistic, negative 2.38, and our p-value 0.0087. Now, when you're using technology, they always use t statistic. They do not use the z. We only use z because we're doing the work by hand. If you're using a computer, you always use the t statistic. So make sure you note that on your homework. Always use t when using technology. And again, you're welcome to use this statistics calculator on all of your homework questions.